Hi guys, I am Emily. I am the developer advocate for Linea. So Linea is a ZK rollup. I'll be going literally from ground zero all the way to let's talk about arithmetization. What does that mean? So let's break down the segment, right? Linea will be a type 2 ZK rollup. What does that mean? So starting from the literal base level, right? So blockchain trilemma is essentially a pick two situation, right? So you have scalability, decentralization, and security. Essentially, you have to pick two of the three, right? So in the case of Ethereum, what they've done is they've chosen decentralization and security. What does this mean then? If we're sacrificing scalability, that is what causes high transaction fees as well as slow speed, right? So how do we fix this? Moving forward, this is the layer 2 solution. So we've started from the ground. We are going one layer up. Well, actually, I guess one layer up from blockchain trilemma, but now we're talking about layer 1. So layer 1 is the underlying foundation and base blockchain, right? So layer 1s take care of your node operators, the producers, the transaction data, and the consensus mechanism. So examples you might have heard of: Bitcoin, Ethereum, I hope you've heard of these, Avalanche, etc., right? And so when we go into layer 2, so Linea is a layer 2, this is a completely separate blockchain, right? So this is the part where we're solving scalability. One thing to note specifically is this piece of data availability, right? So the way rollups work is they're going to roll up a bunch of transactions, and the thing that makes them different is they actually post that transaction data back to Ethereum. So something people often get confused by is if you've heard of Polygon, Polygon is a side chain. So Polygon has its own consensus mechanisms. That data is not posted back to Ethereum, so you're not deriving its security. Obviously, this has changed now with Polygon ZK EVM. That is a layer 2, but Polygon proof of stake is not a layer 2. So that is basically the layer 2 solution. There are multiple different implementations of layer 2s, but right now rollups are the most popular. So now that we know what layer 2s are, let's actually get into the rollup space, right? So what exactly is a rollup? What is it made out of? So rollup has a few different components. The first piece is they have an on-chain contract. So this is a rollup contract that exists on Ethereum. This stores the rollup box, monitors the state, tracks the deposits. I'll get into deposits and withdrawals later. You have the off-chain VM. So like I mentioned before, rollups, layer 2s, help with scalability. The way they do this is they take the execution layer off of Ethereum. So they do all of this through the off-chain virtual machine. And the last piece is it's a bunch of things: operators, validators, aggregators, sequencers, but essentially you can think of them as the people who take all the transactions and then publish that block. So this is the anatomy of a rollup. Like I said, I was going to touch on deposits and withdrawals. So this becomes extremely relevant when we start talking about optimistic versus ZK proofs, right? So asset transfer process, the way rollups essentially work is you basically lock up ETH on this rollup contract, and then equivalent amount of ETH is minted on the L2. So then that's when you start using Linea ETH, or I guess Scroll ETH or whatever ETH on that L2. The other piece is when you go backwards. So now it's I've done all this stuff on Linea. I actually want to withdraw it back on Ethereum. What is that called? It's called withdrawal. The way that works is it's brought onto the ETH on the L2 is burned and then released to your account. This is super key when we start to talk about optimistic versus ZK rollups. So now let's talk about optimistic rollups, right? So with rollups, we're posting that data back to Ethereum. What does that mean is before we do that, Ethereum needs to know whether or not this is true or false, right? So there's different ways of doing it. Optimistic proofs or optimistic rollups use something called fraud proofs. So here specifically, they're called optimistic rollups because they just assume it's valid. That is a less secure trust assumption. The way they get around this is they say, hey, there's a 7-day challenge period, right? And so in 7 days, someone can post a fraud proof to say, hey, this doesn't look right. Let's prove it true or false. And if it turns out to be false, that will be rolled back. If it turns out to be true, it will be pushed down. So again, this is really problematic for immediate liquidity, right? Because of that challenge period. There are existing solutions like trusted bridges that will do that immediately for you. The problem, again, is this is a bridge. The other piece is they haven't solved the use case for how do I immediately withdraw an NFT, for example. So things you have heard of are Optimism, Arbitrum, Base, which is built on top of Optimism's super stack. So now we're talking about zero knowledge rollups. So this becomes relevant for Linea, right? So instead of using a fraud proof, you're using something called a validity proof. Specifically, when we're talking about zero knowledge rollups, that validity proof is a zero knowledge proof. They don't require a challenge period. That information is essentially sent into that proof, generated, and then submitted down. I want to know, when I talk to a lot of people who kind of aren't familiar with the space, they hear zero knowledge and they immediately think privacy. That's not the case. Zero knowledge proofs in this case for rollups are just helping for compression of the data, whereas zero knowledge in other cases, that's going to be a privacy thing. So don't get the two confused. I can talk about that a little bit like offline, or you can ask a question later. But examples include like obviously Linea, but ZK Sync, Polygon, ZK EVM, Scroll, and SnarkNet. So now we've covered, layer 2's rollup, zero knowledge. What do I mean when I say a type 2 ZK rollup? So first off, we need to talk about what is a ZK EVM. So ZK EVM is that virtual machine that will take that smart contract transaction, utilize the Ethereum infrastructure, and also translate that into a way ZK proofs can understand. So this is actually when I talk about arithmetization. This is also why ZK rollups came out after optimistic rollups, right? Because ultimately what a ZK proof is a math proof. How do you translate, computer programs into polynomials that math can prove? That's really hard, right? And then alongside that, Ethereum itself is not very compatible to being able to translate into these math parts. So this is where the ZK EVM comes from. This is where we also start to have the different types. So I'm going to touch on the different types. So at the highest type, that's a type 4. This is high-level language equivalent. So for those of you who are Ethereum devs, that's going to be writing in Solidity, that's writing in Viper. This is actually going to be written or compiled down into kind of a different VM, right? So it's not bytecode compatible. What this means for you as a developer is your tools will change a little bit. So how many of you have deployed a smart contract before? Okay, so most of you, right? So you might be familiar with Hardhat, Foundry, stuff like that. They are not natively able to handle a type 4 ZK EVM. The workaround there is these people actually have plugins. So you might have seen a ZK Sync Hardhat plugin, right? That is because they are not bytecode equivalent. Their thesis is hey, actually Ethereum's not great for ZK proofs. We're going to be faster because we're changing it, right? The next piece is type 3 is kind of a transitionary stage. This is where most of the type 2 rollups are right now. And so by that, I mean Polygon ZK EVM, Linea, Scroll are all going for type 2. So what that means is we are language level equivalent. We are also bytecode equivalent, right? So we are the closest to Ethereum, which is a type 1, then I guess you could say as you go farther away. So in terms of I think the thesis of people or the projects that are chasing type 2 ZK EVMs is you're taking advantage of the existing developer tooling space. You can change the fastest as Ethereum changes because it is constantly changing, right? And yeah, that's kind of the different types. So kind of in the sphere of, is it still not? Okay. Cool. You can pretend that you saw this. Oh yeah, okay, whatever. It's there. Nope. Well, hopefully you have good memory, so you saw what that meant, but it's basically a graph of, I guess, compatibility versus performance, right? So the assertion is essentially the less compatible it is, the easier it is to make it performant. The more compatible it is harder to make it performant. That is true. I'm going to say, I think within the ZK space, the tech is changing. I don't think the assertion that being farther away will make you faster. So I mean, if you just take social proof of people didn't even think ZK rollups could exist, we are at a place where people are building type 2s. There are projects that are also building type 1s. That's not the case. Anyways, I'm going to move to the next slide, and you're not going to see it, which is really sad because I have another really cute Kermit GIF. But essentially, the slide says the same thing from the beginning. Linea will be a type 2 ZK rollup. Hopefully, all of you know what that means now, right? And so now I'm going to talk about exactly what Linea is specifically, right? So Linea is the product of 4 years of research and development at Consensus. We actually started out just doing ZK for kind of payment privacy. And then kind of as we were working on that ZK research, we realized, hey, actually the tech we're building is really compatible for rollups. And that's kind of how we moved into that space. Like I said, we are on the way to ZK EVM. It's really interesting because Our prover is powered by an award-winning ZK circuit library called Gnark. It is open source. It's used by other projects as well. We went public testnet in end of March. At this point, we have over 11 million transactions, 1 million wallet addresses, 196,000 deployed contracts. So the engagement is huge, right? Cool. So kind of like that's the overview of Linea, kind of where you build. So I think something I get a lot is like, there's so many rollups. How do I choose? Right. So there's a few factors to consider, right? So the piece I said, finality. How is that transaction? When can you withdraw it? That's the optimistic versus ZK kind of question, right? So challenge periods, optimistic rollups have that. That's not the best thing for immediate liquidity. When I talk about liquidity, it's like how much people have like already bridged onto the rollup. So my users who are on the rollup already, how easy is it for them to get stuff and interact, etc. The other piece I said is network effects. So this is a lot more so in the sense of as a builder, how easy it is for you to basically develop a dApp. There is a really robust ecosystem around Ethereum already. If you've heard of projects like Starknet, for example, that start off in Cairo, that creates a whole new world where someone needs to learn Cairo to do smart contract security auditing. So what we're saying right here is like EVM equivalence, compatibility. I think that's the winner of something to think about. The last piece is users. Oh, I have two last pieces. Users. So how large is my addressable audience? So as a like entrepreneur, like I obviously want to go where the most people are, right? So that's kind of a thing to consider. And the last piece is security. I think, again, leaning back on trust assumptions, optimistic rollups aren't as trustworthy. I'm not going to say that. I feel like that's really spicy. But the next piece is, when we start to talk about like centralized sequencers versus decentralized sequencers, where does that fit into the security narrative? I'm not going to dive into that because we're talking about how to build. But essentially, kind of how does Linea fit into that system? Those images aren't sitting up exactly, but essentially, like I said, ZK-EVM type 2, I've covered why that's cool. I think the last piece that is really interesting about Linea specifically, so when we tie into that part about liquidity and user base, right? Linea is a consensus product. We sit within the same ecosystem as Metamask, Infura, like Diligence, our own like ETH clients. I think that piece with Metamask is incredibly interesting as like an L2 proposition, is we are there already being able to take advantage of the benefits of the most popular Web3 wallet, right? So when you think kind of to the future in that sense, I think that's the highest value prop in what we offer. Please tell me if you guys actually care more about how the prover works than like how big the audience is, because that would be a really interesting conversation. But anyways, last piece, I guess, is I kind of wanted to go over what that looks like specifically when we talk about language equivalence, bytecode equivalence, and then VM. So as you can see, the farther you get away, the little bit is different. Ultimately, this is kind of where the type 2s are living. And the last piece then is, like I said, on the Linea side, we actually don't think type 4s will be the fastest. Circling back, right, type 4s, their thesis is, we have to depart in order to be fast. I think Linea, our tech right now, we're really focusing on the arithmetization part. So the cool thing about ZK proofs, especially in comparison to optimistic proofs, is you can put a ZK proof on top of a proof, on top of a proof, on top of a proof, and make things smaller and smaller and smaller, right? So you get infinite scale with ZK rollups, recursive ZK rollups, as compared to like a fraud proof, for example. So there's really interesting use cases there. So our thesis is not necessarily that you have to make that decision between type 4 and type 2. So we're going to get into the section of actually how to build on Linea. My Wi-Fi has been kind of funky, so I'm not going to do this necessarily live, but I'll just show you kind of the different ways to do it. The slide didn't immediately change. Oh, here we go. So the first thing you need to do is get Linea ETH. So there's a few ways to do it. You can bridge it over to Linea, Girly ETH to Linea. The other second method hasn't come out yet. But we are building an Infura faucet to drip test ETH directly onto Linea. The third method, specifically for you ETH Lisbon builders out there, is I am a Linea ETH whale. So please feel free to leverage me as your faucet. You can find us on Discord. Reach out to me afterwards. I will literally send it to you right now. Emma's over here. He's BD at Linea. He also has a lot, so take advantage of both of us. Yeah, but only at Lisbon. If you talk to me afterwards, I'm just kidding. I'll always be nice to you. But essentially, like when I talk about the ease of use with a Type 2 ZK AVM, it's literally just swapping out your RPC, right? So when we talk about Truffle, like that's a smart contract tool. If you are starting with Truffle, I recommend using their Next.js box. It's basically a full system of smart contracts connected to a front end with tests and everything. The only thing you need to do, actually, maybe I can demo this. I'll show you. Yeah. Wow. Okay, is this big enough? Okay. So this is Truffle dashboard. You can use this with Hardhat as well. Let me open up code dev slash Linea demos? Is this where it is? I don't remember. I'm just gonna say it was here. Okay, no. I don't know where I'm at right now. So I'm just gonna exit out here. Do this first. Because I know where that is. Okay, here's the terminal. So I'm gonna do a Truffle dashboard. Here is the thing. So this does deployment through your Metamask wallet. If you wanted to deploy on Gurley, you would just use Gurley. In this case, you can just switch the network over to Linea. I need to click to connect. And the difference here then would just be CD Truffle and then Truffle migrate network dashboard. So this is cool because I didn't have to show you my private key at all to deploy, which is really nice. This is also usable with Hardhat, but as you can see, the difference between Gurley and Linea was literally just switching your Metamask wallet, right? So when we go back to kind of the different tools, the same thing. I don't know how many of you guys use Scaffold ETH. It's pretty common, I think, for hackathon devs. Literally just change the default network. Oh, all the screenshots aren't showing up. Okay, I can try and open up the code. We'll see if it's working. Yeah, okay, so basically this is the Scaffold ETH repo. You just change your default network, like Gurley versus Linea or something. You just swap out the RPC URL. So if you look at the Gurley one, this is what it is. That's a fake Infura API. All I did was say, hey, now let me rename this. And that was deploy on Hardhat. So kind of the same thing. You can do dashboard with Hardhat if you want. And the last piece is Foundry. Download it again. Wow, so easy. You just swap it out. Damn, no one clapped with me. That's really awkward. Cool. Okay, so anyways, feel free to get in touch. There was a QR code with my information, but that's fine. Let me know if you have any questions. I don't know if I have time right now. Okay, I have like 10 minutes for questions, or we can talk privately. But yeah, that's my information. Feel free to message me for Linea ETH. If you are hacking, we have a bounty specifically that says just deploy on Linea. If you're deploying a smart contract, swap out the RPC, ask me or Emma for some Linea ETH, and you should be eligible. So yeah, that is it. Thank you so much for listening. I hope you learned something today. Are there any questions? What's going on? No questions? Okay, we are good. Thank you so much for listening. I wish you the best of ETH Lisbon. I hope I recognize your face during judging. Okay?